This tutorial will show how to include P-delta effects in a SAP2000 analysis. There are two primary ways to include P-delta. One is to create a static nonlinear load case for each load combination that includes P-delta. This is the most accurate, but is limited to static analyses only. The second is to create a so-called initial P-delta load case using anticipated gravity loads, and then use this modified stiffness matrix for all the other load cases, including modal, response spectrum, and time history cases. We will show both methods. For our model, we will use a single column object. We start by applying a dead load of 100 kips at the top. And a lateral load of 10 kips also at the top joint. For the first method, we will define a new load case to represent the dead plus lateral load combination. This will be a static load, but nonlinear, so that we may include P-delta. Even though P-delta is a nonlinear effect, it may be utilized in all levels of the program. For this case, we will combine the dead and lateral loads together with factors of 1. Although any multipliers may be used to match code or other requirements. We are now ready to run the analysis. We will open a second window so that we may compare results side by side. First, we will display the results of the lateral analysis, which does not include any P-delta effects. The lateral displacement is 2.58 inches. Next, we will display the displacements due to the nonlinear static case, which includes P-delta. Here, the lateral displacement is 3.48 inches. Noticeably larger due to the softening effects of the compression dead load. We will also display the moments due to each case. A right click on the object allows us to pull up the member diagrams, which shows a maximum moment of 1200. For the nonlinear static case, right-clicking shows a moment of 1548. Again, the moment is noticeably larger than in the case without P-delta. Next, we will unlock the model to illustrate the second approach to including P-delta. We will define a new load case to represent the initial P-delta. This case may then be used to modify the stiffness of other cases. This case will again be static, and nonlinear. And again, we select the P-delta option. However, in this case, only the dead load will be applied with a multiplier of 1. Next, we create another load case for the dead plus lateral load combination. This time, this combination will be linearly static, but we'll use the stiffness at the end of the P-delta analysis case. Here, the case will apply both dead and lateral with multipliers of 1. We are again ready to run the analysis. This time, we will display the nonlinear static load case in the left window. And the linear static load case with the initial P delta in the right window. Note that the displacements are nearly identical. A comparison of moments shows that they are also very similar for the two different P-delta techniques. The inaccuracies in the initial P-delta approach stem from the fact that the loads or load factors used in the various combinations may differ from the loads used when modifying the stiffness in the P-delta case. However, the advantage with the initial P-delta approach is that you do not need to perform a nonlinear analysis for each combination, and it can be used in a dynamic analysis. We will illustrate that now with a modal analysis. Our default modal analysis case uses 0 initial conditions and requests one mode, and we will leave it as is. However, we will add another modal case, which we will call PD modal. In which we will use the stiffness from our initial P-delta case. After running the analysis, we will display the unmodified modal analysis in the left window. And the P-delta modal case in the right. Note that the period of the first mode with the P-delta included has lengthened due to the compression softening. Again, running each load combination as a static nonlinear analysis case will give the most accurate P-delta analysis results. However, for most buildings, setting up a single initial P-delta nonlinear case and then using the modified stiffness from this case in each of the other analyses, including dynamic cases, will give appropriate results. This concludes this tutorial on P-delta analysis.